No, actually, do first. And the Constitution. I don't remember the last Gen 2. The last member. He graduated.
Wait,
no more than 2 years.
Who used Gen 2? Was it Nate or
He used Gen 2.
Oh. That sounds about right.
Yeah.
What is Gen 2?
It's a operating system that you have to compile. Wait, do you have to compile it yourself? Or?
Yes, compile it.
Yeah, you have to compile a Linux kernel yourself.
Yeah, if that's not satisfactory, just use an
Is that even worse than hard at this point?
Yeah, it is like more extreme than Arch.
All right, well, good afternoon, everyone. We've had an exciting start to the afternoon. Good thing the assignment was due last night, so no one should be asking us for any extensions, but if you need to submit the homework late,
If they want to submit today, they should email it to you.
they should email it to us. These are our emails over there.
Preferably all three, not just one of us.
Yeah. And homework 4 is out.
Not anymore.
It is out.
Wait, is it on the site yet?
It is on the site, so
On the
it's
site.
it's over here. It's the Linux penetration testing. Please stay in scope. Don't do something like this.
Canvas is not in scope, by the way.
Canvas has never been in scope. Let's make that very clear.
Unless you guys like mix up the name of one of the dummy names to an instructor name, then you have the rights.
So the only thing that's on Canvas that's not accessible on the website is our feedback form. But no feedback now. We'll deal with that next week. But
can put
all.
it in Discord or whatever.
Yeah, we can put it in Discord. But for the assignment, it's due next Sunday. Not this coming one, but the next one. Yeah. Any questions? All right. Well, today's topic is exactly this. We're going to talk about, not the right side, the left-hand side, Linux penetration testing. Let's see if my VM would want to run here. Okay. Yeah, let's do that. Should have restarted this whole thing. Okay. So, today's topic is going to be Metasploit, which is one of the easiest ways to, get started in hacking something. So if you remember lecture 8, we talked about how we would go through a full penetration testing. So we went through reconnaissance, scanning, exploitation, post-exploitation report. So today's main topic is going to be about the exploitation phase. How do we actually hack into something? And we're going to be going through this Hack the Box lab. I might skip through a few steps because, again, I have the answers, you don't. On the homework, you will face a lot of difficulties that you won't see me facing today. So just know that that's a normal process of penetration testing. It's a lot of, let's look at everything that we can do. What can I do next? And a lot of times they may be dead ends, and that's okay. All right, so let's see if this is going to start running. Let's do this. Oh, does my VPN have? All right, this should be up when this machine is up. So let's talk about what Metasploit is in the first place. So Metasploit, as you can see, is one of the world's most used penetration testing framework. It looks something like this. Can people see? Okay, let me zoom in. Can I zoom in? Okay, doesn't like my controls. So this is what Metasploit looks like. When you go in, you type MSF console, and you get brought to this page, and you can run a lot of things directly from Metasploit. So you can load payloads, you can try to execute command and control, you can do scanning. All of that Metasploit is capable of. It's run by this company, Rapid7, and so they've carefully crafted all these specific vulnerabilities that are well known that you can use. And sometimes when it's here, it's very useful, sometimes it's not, and we'll talk about what you will do in those scenarios. Let's see, okay. The IP is good, so IP is 10.129.58.116. Okay. So, who remembers when you have a new machine, what's the first thing you want to do?
And that's a map.
Nmap. Perfect. So you can actually do this straight in Metasploit. So instead of using the regular Nmap, I use db_nmap and the same flags that you might usually want to do. So I like to do -svc, all the ports 10.129.58.116. And the reason why you want to do this in Metasploit as opposed to outside, even though it will return the same results, is Metasploit will actually capture information about these scans, and so it will allow you to use some of these variables that get saved into the database when you do exploitations later on. So right now, I know I have to use this 10.ip address. I'll probably forget it later on. I can just use this variable that it gets saved automatically in Metasploit later on. I can also do a lot of other things like all the services that gets listed, all the port numbers. It will also be saved in the database, so I can just refer to them later on. So that's why when we talk about Metasploit, it's really a suite of tools that you can do scanning, vulnerability assessments, exploitation, and post-exploitation all wrapped together. So while the Nmap is running, let's take a look at what the modules are. So in Metasploit, there are these 4 modules. So auxiliary, exploit, payloads, and post. So auxiliary is things like what we're doing right now, using Nmap. It gathers all the data. There are other things that you can do. You can list them in Metasploit. But for our purposes, we'll just look at Nmap for now. Then we're going to do exploit. So when you have looked at all these scans and you've looked at all the results and you try to play around with them and you found certain exploits, and we'll talk about how you find them, then you can see if their Metasploit itself has that particular exploit, and you can try to run those codes on the machine. And then you can inject the payload, which allows you to, say, get a reverse shell on the machine, so that you can continuously access a session on the machine. Post-exploitation is, again, what it says. After you've been compromised, can you do something like privilege escalation, more enumeration of data? That's what Metasploit does. So really is like the fundamentals of all you need to know about hacking or penetration testing, all wrapped into one tool. Very, very useful. Okay, this Nmap scan is taking forever. So I will just tell you, there's a website on here, which for any penetration testing, if you have some IPs, very good habit is to just, see if you can query directly on the web page something over there, which is 10.129.58.116. So we look at this, and of course, there's a web page. Okay, so now that we know that there's a web page, we'll look at the scan later on. What's the next thing that we should do? We talked about this as well. What's one thing you can do with the website? Inspect, okay. Well, let's talk about just running tools, because the first things you want to do is scan any information as much as possible. We talked about hidden links, exactly. And what tool would you use? GoBuster, perfect. So we can use GoBuster to do that. Okay, so GoBuster is actually pretty slow, so I'm going to use something faster. So this is Feroxbuster. It's written in Rust. So it is, I actually compared the tests with GoBuster. It's significantly faster. Okay, it needs to be --insecure because it's not HTTPS. So now you can already see it's already giving you some maybe useful information. You can see there's like an API endpoint and your regular web admin stuff, but I think web admin was the default page already. So let's take a look at this API. Oh no, did I mess something up?
That's API images, I think? Oh, there's, okay, never mind.
It should be API. Okay. Okay. Is it going to let me load?
No.
Okay, my VM is freezing. Wonderful. As usual, technology problems.
Guys, stop doing your homework crossing.
Okay. That's why I have printed materials while this thing loads. Alright, so I'll tell you what the Nmap scan tells you. There's a port 22, which, as you should know, it's SSH, port 80 and 443, which is web, and that's it. Really all that is that's running on here. So
Can you zoom in a little more?
I'd love to, I just don't know how to.
Go plus, go shift plus.
No, it doesn't.
What is this? ZSH?
Oh, here we go, okay. There we go, okay. It is working. So it's still scanning. I think it's working now, so I can come back. Okay. Oh. Let's try this again. I don't know why it's doing that. Anyways, but you can look at all the endpoints and all of that. It's somewhat helpful.
You like API or API slash after?
Let's see. API slash. When I tried this last night, it was working. But okay. Oh, it's HTTPS. I remember now. Yeah. Okay. Thanks for logging me out.
Yeah, I don't know why it logs out like in 30 seconds or something. It didn't do anything.
Okay, and it's had to kill everything too. Okay, so it's HTTPS/API. That's what it was doing. So if I do this, yeah, that's fine. Okay, so you get a bunch of endpoints. You can try and play around with this. You can play around with the logins page. All of that is nice. What is actually useful was if I come back to this screen over here, there was actually something over here. I can download these things, so let's actually click on some of these buttons and download all of this stuff. Yeah, save the file, and then open the file. Okay. Can I open? Okay, no. Oh shoot. Okay. Really hates me today. Good thing is I have a team-up session, so this is still saved, even though my Firefox isn't. So what we'll do is just come to downloads, and then we will look at the web start. So that's the one that we downloaded. So what you should look at is, first things that some of you will do is actually take a look at the scan and see if the site itself is actually running anything vulnerable. And it turns out this Mirth Connect Administrator 4.4.0 is vulnerable, and we can do it. And what you would do is you would Google all this stuff. So OSINT and all of that is very useful. Give me a browser. Okay, Mirth Connect 4.4.0. So you can see it immediately tells you enumerating the RCE. RCE is Remote Code Execution vulnerability on Mirth Connect 4.4.0. So it's very helpful. You know there's something going on over here. So what we can do is, now that we know there's something vulnerable going on, is we can come back to our Metasploit session. Okay, this Nmap is not going to finish running, so I'll just kill this. Normally, you should wait for it to finish running, and you should do all of this, fancy enumeration, look at all the things that are on the website, scan everything, but I'll skip all of that, just going through the process here. So let's actually do the search. So we said there's something called Mirth Connect. Oh no, spelled search wrong. So I query Metasploit, and it will tell you that there's a CVE that it has, CV2023-43208. And if you looked at this, this is exactly that. Next Gen Healthcare Mirth Connect before version 4.4.1 is vulnerable to unauthenticated remote code execution, CV2023-43208. So that should tell you that on Metasploit, this code that you can use to attack it is already there. So it's very easy for us to just exploit it. And you do that by simply coming over here. We're going to use 0 because we just searched it. So you can just tell it, I'm going to use the exploit 0. So now you can see no payload configure default to that, but you can see we're at this exploit mode over there. I'll try to zoom in for the ones at the back, but it tells you exploit is now at this multi HTTP Mirth Connect CV 2023-483-208. Great. What do we do now? So what I can do is I can just show all the options of what I can do. Okay. That's why you don't zoom in. Okay. So these are the module options. It tells you about all these things: R hosts, R port, proxies, SSL, bunch of stuff. So now we should actually talk about what this is doing, right? What does this exploit and what does this payload mean? In Metasploit, when we have exploits, what it's doing is trying to use the vulnerability that exists on these systems and put a payload onto the server so you can connect to it. And now we have to talk about this idea of reverse shells. Who knows what a reverse shell is? Okay, who knows what a shell is? What's a shell?
It's the main program the thing we use for the whole program, basically. The
Right.
execution
It's a program that we can use to access, and query things on a machine. And we want to get a shell access to, whatever this machine is doing, right? This vulnerable server. That's what we want. We want to get access to it. But it's very rare that we, unless you have credentials, to immediately sign on to that server. So what we actually want is we want to dump something on the server so that it will come and talk to us. So usually, this is our laptop over here. And we talk to the server, and the server, and we instantiate the connection over here, right? We say, let me open an SSH session, give me a shell. What we want to do is instead of telling them we want an SSH session over here, we dump a payload, so some executable over here, such that when the server executes, it thinks it's the computer and we're the server.
So they ask you.
So they ask us for a connection. And why do we want to do that? And most of the time, it's because we want to evade detection. When we talk about firewalls in a couple of lectures, a lot of connections are refused by inbound connections. Like, you can't just try to talk to random people, right? But you always allow outbound. So for example, my laptop over here is connected to the network. You don't want someone to randomly knock on the door and say, I want to connect to my laptop. That's not good. But you need to be able to talk to Google and all of that. So how it works is it allows all the outgoing connections, because I can talk to Google and Google can respond back. And so this also helps evade firewall detections, because when the firewall sits over here, it's like, well, I'm not the one initiating the conversation over here. The server is, so that's allowed. So it will try and send a connection back over here. And what we can do is, well, we have to set some variables. So the typical variables that you want to set in Metasploit are these. So it's R host. So R is the receiving. So from our standpoint, this is what we want to be receiving the payload, because we're trying to send a payload over there. So we should set the R hosts. So we do set R hosts to the original IP, which was, I wrote it down somewhere, 10.129.58.116. So it knows what it's listening to, but we need to tell them which port it is that we're trying to exploit here. Which port are we exploiting here?
80.
Okay, 80 is one of them, or 443. We'll use 443 because, as we've just shown, some of the endpoints are only available in HTTPS, so we should maximize our chances. Set our port to 443. I spelled that wrong. What'd you say?
80 is just for HTTP.
80 is usually reserved for HTTP, 443 is usually reserved for HTTPS.
For both. That's okay.
What ends up happening, some sometimes it's, if you try and make an HTTPS connection on port 80, it'll automatically redirect you to use 443. But you can, the laziest way to do it is if you try and use HTTPS to port 80, it won't work. But I guess the also thing you have to consider is when you type in a URL, HTTP : it automatically assumes port 80. You don't have to type it because it will automatically go to port 80. If you type HTTPS, it will automatically go to port 443. If you want to use something else, you have to specify, but the default is kind of in the URL itself.
Thank you. So we tell Metasploit where we want to deploy it, but it needs to, when it dumps the payload, it needs to know where it needs to talk back to. And so that means it needs to know our IP address. And so we have a command for that. Who knows what the command is? How do we find our IP address? Okay.
IP config is Linux. I'll remember that. But I think on Linux you can use ifconfig.
ifconfig should work. So we have the IP address over there. We're on ton 0. So on Metasploit, we should be able to just set the L host. L is being us. We're the one that's going to be listening to the connection to ton 0. And that works because ton 0 is 10.10.14.219, as we just saw. And yeah, so we can do options again, just to confirm that that's everything we set. We have our R hosts set to the server. The port is 443. SSL is true because we want to connect to the TLS site, the secure site. And we have the listening host. Where's the listening host?
So you give it the tunnel numbers, not the IP itself?
You give it because
Ton 0 is set, like on my machine, ton 0, if we come back and look at the IP address, ton 0 is 10.10.14.219.
Yeah,
but
I thought you give it the number. You just give it the tunnel where the number is.
so you can give it the IP address, but Metasploit is smart enough that if I just tell it I'm on ton 0, it will automatically translate it to the IP address. And that's over here. I'll host it, automatically set it to my IP over there.
Yeah.
So, any questions? Okay, so now I can just run this exploit. So let's hit run, and I will tell you this is going to fail for now. Not in the way that you think it's going to fail. So it will tell you target appears to have executed the payload. Exploit complete, but no session was created. And this is the fun part about Metasploit, is there are a lot of different payloads. So if we refreshed our memory over here, and we came all the way up here, when I said use 0 over here, it says no payload configured defaulting to command Linux HTTP x64 meterpreter reverse TCP. So it didn't know what payload to use, it just chose one at random. It chose the most beefy option. Meterpreter is a very capable reverse shell. It's telling you it's running on the TCP connection. Very, very powerful thing that it can do. Includes a lot more tools, and one of the benefits of Meterpreter is actually it instantiates a shell purely on memory. But as we can see, this payload didn't actually work.
Is it visible for those of you in the back, or do you want it zoomed in?
it's fine.
So that means that this payload was probably too beefy for it to execute properly. Like the limitations were too high because this Meterpreter will only put it in memory, helps evade detection and everything. But for our purposes, we don't really care about the detection right now. We want to gain a shell. And we know that it told us that the exploit itself was successful. So it just happened that our payload, that whatever we gave it, didn't really work. So we can actually show all the payloads. And there are 409 different payloads that you can configure your shell to use, like the payload itself. So some of the most common things that you want to look at are any of the reverse ones. So from 374 all the way to 402, those are just normal reverse shells. It tells you it's reverse versus TCP or UDP. And there are those that are, what I call more beefier, more constrained, where it says TFTP uses, TFTP, which is the trivial file transfer protocol, makes it hard to detect. So if you want to, try to ensure that you can get something, you would try to go for one of the little ones over here that are simpler. You just try and put a shell in. It might be easier for a network administrator to detect what's going on.
Can you elevate yourself once you get decommissioned?
That's the good point. That's the next point that I was going to talk about is you can come in over there and you can use Metasploit actually in the post-exploitation phase. So if you remember over here, after you create the payload, your post modules actually sometimes will have other payloads that you can use to elevate your shell from a more basic one to something like Meterpreter. But that's not always supported. For this one, I will tell you we can use reverse bash. So that's 376. So I should be able to say set, payload to 376. So now that's the payload that I'm going to do. Double check my options. You can see there are a lot less options compared to before because this is, again, more basic thing. Meterpreter is much beefier, and you're just going to try and get a shell. So what we're going to do is we're going to run this. So going to craft the thing. The target appears to have executed the payload, and now we're waiting. Seems like something's happening over here. Command shell session 1 opened. So now I actually have a shell. And as you can immediately see, it's not your typical shell. And that's why usually you want Meterpreter, because this shell is so basic, it doesn't even tell you where you are, it tells you nothing. You can do your normal commands, like I can try to print working directory. It tells me I'm there at /user/local mirth connect. I can do my ls, I can do cd, all that fun stuff. But it has no nice, visual indications. They're not even a $sign. There's literally nothing. It's a very, very basic shell.
At its core, all it's doing is just taking whatever you put in when you hit enter, sending it to shell, and then sending back
The response that it gets.
And I think the response is like just standard output. You don't get anything, nothing fancy.
So zero privilege instruction at this point.
Okay, so we can do this. Who am I? I'm Mirth. What permissions do I have? I have these permissions. ID is 103, group ID is just Mirth, groups is 111. So you have some local user essentially, probably the default server user that it configs. They may have changed the password. Now you got a shell up there. So now what do? You should do all your classic stuff, which is enumerate everything. And because I did. I like this view better because now I can actually know which ones are directories and which ones are files.
Doesn't LSL allow you to know that as well?
Yeah, it does. I always use halter. I'm just used to that, but you can use
formatting?
H is for human readable, so I know how big the things are.
Oh, cool. Okay.
A is for all, so I see the dot files. L is for the long listing. T is for in time, so if whatever file is modified last should show up at the top. I used R to reverse it, so I can see that conf was the thing that was modified the latest. So maybe that's something I should check out first. So cd into conf, and then I can do the same thing. And I have these interesting things, some properties files and all of that. So I'll tell you, you should look into all these files. And if I look at mirth.properties, and you can see I'm typing all of this up because this shell also doesn't support tab completion. And this is very common. So that's why if you're able to further exploit into the next stage, you should. This exploit in particular doesn't support the next level. Like there's no post-exploitation package that's within this CVE. And CVE, again, is a common vulnerability and exposure. It's something that when white hat hackers, not the ones that broke into Canvas, obviously, find vulnerabilities, they report it to the, hopefully they report it to whoever's maintaining the software first, and then they publish a report to the CVE organization, so they get a CVE number, and these numbers are listed in this public database, so everyone knows that these vulnerabilities exist. There's a one-stop shop for a central database for all the different vulnerabilities. So from our standpoint, if you want to hack something, it's all there. But also as a defender, you know if you want to defend against vulnerabilities, it's also over there. So everything's centralized.
It's just there for grabbers at this point.
Yes, so that's why when we say like you should always update your software when there's new software updates, it's exactly for this reason, because once something is out there, it is out there, right? If the hackers have it, the defenders also have it, everyone has it. So when something is, when you have a new software update, even if the code isn't publicly available, hackers are able to look at the differential. So for example, my Mac has a new update, right? They know what the previous software version looked like, and they know what the new software version looked like. They can just do a diff, and they can find everything that's been changed in the software. And so they will be able to quickly find all the vulnerabilities that Apple has patched, or maybe in Windows it's Microsoft, in Linux it's, or Linus Torvalds put into, and Linux is even better because all that is open source. So they don't even have to reverse engineer anything. Before, Windows and Mac, all that's closed source. So they find a diff, they reverse engineer all the patches that the vendors have applied, and then they can already find all the vulnerabilities. So within 72 hours, there is an exploit in the wild.
What's crazy is like even though Linux is open source, it's way less hacked than Windows. Like they usually if they're gonna hack, they hack Windows first, easier than Mac or Linux.
So that's a whole separate discussion as to why that's the case. I have my opinions.
Philosophy. We'll talk philosophy at the club meetings.
We'll say that part.
But yeah, so anyways, please patch your devices. It's been known that as quick as like 4 minutes, like some OS has already been like, within the patch, someone has already reverse engineered the whole thing. And with AI, it's only going to be faster. Anyway, so let's look at this mirth properties. You'll find some very interesting information in here. Part of which, let's see if I can do this. Oh, it's actually over here. It's right here. Over there. So there's a database URL. It tells us that there's some database that's connected to it. It gives us the whole URL, and it gives us database credentials. So very helpful thing for us. So we can actually just look at the database. It's a SQL database. And now that you have credentials, you can just show all the tables and get some information. So I'll tell you that after you do all that, you'll get a password hash. We haven't talked about password cracking. We'll do that in the future. But you can crack the password, and you'll be able to find that there is a user called, what's the user called? Cedric. The user is called Cedric, and there's a password called snowflake ! Or something like that, I think. Yeah, snowflake1. So I'm gonna skip over the step of going to the database, showing the tables and everything, and we'll move on to the next step. So gives us credentials for an SSH session, so we can actually just SSH into something. As I said, it's Cedric at this IP, which is 10. Oh my, where'd the IP go? 10.129.58.116. Yes, and the password was snowflake1. Okay, so now I have an SSH shell. If I'm doing hack the box, you have to remember you have the user.txt. So that's my user flag. I'm going to take the flag and do what I want with it. Put it into hack the box, get my flag, whatever. So the next thing is.
I wonder if there's a flag or is that just Windows server text?
So we had this conversation last time. We did a hack the box challenge, but hack the box always has a user.txt and a root.txt on the root. And those are the two flags that you look for. So if I come back to the challenge over here, I can actually just do that. So let me just copy this. Can I copy? Does it let me copy? Okay, it doesn't. But if I paste that in there somehow, it should like the flag. Yeah. So that's user.txt. And now we have to get into this root file over here. So last time, I didn't have time to show everything to you. I just mumbled through some steps, and I said you can do this, you can do that, and you should be able to do a privilege escalation in lecture 8. So who remembers what I said? How can we do privilege escalation on Linux? Yes.
There's a random script on the internet and you just run.
Yes, that's correct. There's a random script on the internet you can just run. What script is that? Script is called linps. It stands for Linux Privilege Escalation Awesome Script, I think. If it loads.
Do a recording check.
Recording check. Yeah, it's working.
Alright, excellent.
So we come to this repo over here. And we should pull linps, and then we will do something to send it over. So now we're on the SSH session, right? We did the reverse proxy, we got shell, we found credentials that we can log in direct via SSH as a normal database user. So now we're logged in via SSH. We want to get this linps file onto the server.
Don't you just disconnect and do src the file to the directory that you ran? Or
You want you can try to do a secure copy. Yes, might work. Why is linps not loading?
Bro, we got taken over well.
No way they got pwned as well.
VPN. I mean, if you just go to just like Google linps on Google and just like go to the first result, it should load pretty much instantly. I don't know why your internet is.
Yeah, because I'm inside this VM, and VMs hate me. That's why I wanted to do my best to avoid. Okay, actually, I can do something different. No, I can't, because I can't set up a Python server on my Mac OS because Mac will refuse to let me do nice networking stuff like that.
can you set it to the?
We can try that.
You're using the DPI, right?
Or why not just use Safari?
No, why not just use Linux?
It's
Okay.
on Mac. That's like basically. It's like a cousin, close cousin.
It's not the original.
Yeah, I play.
Well, Linux isn't the original either. The original
Yeah.
is Unix.
Yeah.
So we will.
It's more awesome.
Cool. Let's try this.
I'm just gonna send a link in 198F Discord. You can take a look at it yourself. I'll put it in general. There doesn't need to be an announcement.
I have a feeling this is not going to work. Oh, I know why it's not going to work. That's because I'm not on the VPN.
What if you got off
No, as in I'm not on the Hack the Box VPN on here.
the
Downloads.
We have this Discord, you can just take it there.
Okay, let's try this again. Okay, let's try this. Yes.
Oh, you're trying to pull it off. Oh.
Let's see. Let's try secure copy. Oh. Did I put in the password wrong? What was the password?
Do you have the password?
I have the password, and I forgot the password, so I have to go find the password again. Okay, looks like it transferred over, so let's see. Cedric at 10.129.5.16. Okay. Okay, linps is on here. So what we can just do is we can just believe we can meet chmod.
Yeah.
SX linps. Let's run linps. Okay. So now it's running this. So we'll just let it run.
Answer some questions about how to get the linp script onto the box. SCP would work if you had SSH credentials. You might not always be in a position where you have like a password. You might just have, just like a web shell, or not web shell, you just have that shell that you put in with Metasploit with like really bare bones, right? So, I mean, you might not be able to copy it over with SCP, but there's other Linux utilities that you can download things with. Does anyone remember what Linux programs you can use to download things? Just throw them out. Pro? One more I'm thinking of, but
Okay.
yeah, wget. You can just download, curl and wget are just, oh, let me get this web page. There are techniques for just serving files as web pages, so I assume you'll talk about the curl and wget and stuff.
And yeah, access the browser from like that limited access thing.
Yes, but again, we don't have the servers are headless, right? There's no web browser on there. So if you want to get stuff from the server, onto the server from the internet,
You can't just run.
you can't just like run
That's what
Firefox.
I'm saying. You cannot just install it. That's my question.
Oh no, because there's no graphical user interface on here, right? Like we don't have any way of getting a graphical user interface because it's normally not needed.
We're saying.
Did you also just do like TEOF and then copy paste the entire SH here?
Oh, you just like copy and paste it into like a text terminal? Yeah, I mean,
Yeah.
you could do that.
Do like nano file and whatever.
It's
Paste the whole code.
yeah, but I mean actually, Ethan, do you wanna? I don't know if you still have that shell open. Do you want to try running nano and see what happens in that limited shell?
Yeah, we can try that. My VM just doesn't want to work for me now.
Just echo the entire thing and just redirect it to a file.
Yeah.
That is like the.
Let's pause this. Let's restart this.
Suspended you.
Yeah, it hates me. That's what I realized last night. Computers really hate me. Alright, so what's going on over here? Okay, this thing is frozen too. Wonderful. Okay.
Did you not suspend it or?
Okay. No, this is the server on Hack the Box. That's not suspended. Okay. So anyways, what did I want to find over here? So what you normally do is you actually look through this whole file. It tells you all interesting stuff. So let's actually scroll up and see. Basic information. It runs, ID. So it tells me that I'm Cedric, I'm group Cedric and all of that. Nothing interesting. System information, blah, blah, blah.
Very helpful color guide in the beginning where it's like you should look at this or exploitable. It's a lot of information, but they color coded it for your enjoyment.
So it tells me all the things about the environment, and it gives you some signature stuff, blah, 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 blah. Running processes, so this is like a nice colored PS aux. Okay. Of course it did. Why would it not kill my session? Why am I doing this? Up arrow. Okay, I guess we just run this again. Okay, so while this is running, opened files, so that's still not useful information that we have. Eventually it'll come down, you will start to see, okay, here you can see checking for CVEs. It'll run it against a database of CVEs that are known. And eventually it will either tell you there are some known CVEs that you can try to exploit, or that there are some interesting files that might allow you to run privilege escalations directly. And I guess this now is a good time to just go over some theory. So some of the theory that we want to talk about is when you do an ls-l, you have your RWX, for example, root, wheel, and your file name. So what this means is root has read, write, execute, wheel, which is the group, has read, write, execute, and everyone else has read, write, execute. But sometimes you might see some files that are owned by root that have some type of executable privilege and that you have some write privilege to. And if root, you can somehow get root to run that process as root, you might be able to get a shell that way. There's also this thing called the set UID bit. I believe it's like over here. or over here, I forgot. There was a set UID bit. I think it's the very first one, so RWS, something like this. And this means that when a process runs, it always runs as root, even if you're the one running it. So a program, for an example, that has the set UID bit, of course it does. So there are some programs that you must run as root. One of the most famous programs that has to run as root is the SU program. Who remembers what the SU program is? SU is the substitute user program. So if I actually do ls-l, which SU, you can see this over here, RWS, RX, RX. So the whole program is run, it's owned by root. I don't have any write permissions to the program, but when I execute the program, normally I execute it under my permissions. But this has to execute under root privileges because you can change into a different user. Normally you can't change into a different user. Only root can do so. So you're temporarily escalating this yourself to root privileges to run this program. The program itself will check whether or not you're actually allowed to swap into another user, and then either return you a shell to that other user or deny you access. And so if we're able to somehow compromise these programs, then you're toast, right? Then you can just pretend to be root and run whatever you want. And so a very common tactic to these privilege escalation is when you have a shell as a normal user, you try to find areas where you can escalate yourself into root via these types of set UID or some of the CVEs that you might find. Is this done running yet? Okay. Doesn't look like it. So anyways, I'll just tell you that there's a way to find, so after you run linps, after you do it for a long, long while, apparently, I don't know why it's taking so long, you will be able to find some files that have root privileges that you might be able to take advantage of. It'll be listed in linps. And yeah, so we'll revisit this at a later time. Right now, what I'm going to do is kill this and switch over to different demo. So this is something that we set up today. It is a box that we have that I want to demonstrate something. So what's going on over here? Shoot. Okay, here we go. So far what we've done is we've executed payloads via Metasploit, right, to try and obtain a shell. But sometimes Metasploit might not have the package that you want, but there is a known exploit in the wild. And so we've contrived this example where we have this very vulnerable Linux machine, and we've ran linps on it, and I've searched for the string CVE. And over here, you might be able to find that, okay, that was not the CV I was looking for. Okay. Okay, what's going on over here? Okay, but anyways, you run linps and it'll tell you that there is an exploit called this one, CV2021-4034. And as you can see over here, there's a POC, a proof of compromise, that's on GitHub. And this is something that we can just use, even though it might not be our Metasploit, to try and do a privilege escalation. And what we do is we literally just read through what it does, and it tells you, very helpful, that there is a one-liner command that you can easily exploit the system using a single script and download and execute that. And to tell you how easy it is to do, I will literally just demonstrate for you. I don't know what that is, but I will do ID. I'm UID, so I don't have a root. I'm in this user called no root. I will try to do something sudo. So sudo, su. I put in my password. I'm not in the sudoers file, so I don't actually have sudo privileges. I'm just a normal user, but if you ran linps on it, you should have been able to see that I'm vulnerable. Actually, I should be able to run linps on here. Let's actually try to do that too. So linps also has a very nice one-liner script, by the way. You can just do this. So a lot of these GitHub things, they have nice scripts. So let's just run linps on here. Anyways, we'll let it run, but we'll execute this proof of concept code over here with this one-liner command that after we ran linps, we have figured out that this exploit is doable. So we'll hit this, eval this, and as you can see, I went from the $, which is a local user, to hashtag or the pound symbol or the octothorpe symbol if you're fancy. And that means I should be in root. I should have root privileges. Who am I? Oh, I'm root. ID 0. I can do sudo stuff now. Sudo etc shadow for an example. Oh, because I have to cat that. Cat etc shadow. And now I have all the password hashes of the box. Coming back to linps, it's still running. So you can see there's a lot of things that are going on over here on this box. It's very, very vulnerable, actually. If I do this, will it like this? What did I do? Wow, linps is taking a really long time. Yes, I know that. What is going on? Okay, I somehow managed to kill that session. Hi, Ethan. What? I don't know what's going on anymore.
I think we're having
You have to be back.
next job.
Oh no. Okay, I'm back over here, I think. Or not? Okay, I'm back over here. Okay, thank goodness. I don't know what the hi Ethan was.
That's crazy from the system, man.
Okay. Okay, so I'm going to search for CVE. So, there's a lot of CVEs. Oh, it's not done running yet. Okay. Okay. I've successfully killed my computer. Okay, whatever. But anyways, that's the lesson to be learned. You have ways to execute payloads, even though they might not be a Metasploit. So what you should be doing is, like, if we talk about the standard playbook, right? In the exploitation phase, like, what do we need to do? Well, first thing as usual is we run, the default tools, whether it's GoBuster or something faster like FurOxBuster, and you should be able to get directory traversaries on web pages. But not everything is on web, and you can use Metasploit to try and figure out the different payloads based on other information that you might be finding on the server. So sometimes Nmap itself will actually be very helpful and tell you that some services might look vulnerable, and that's what the -s flag and the -b flag will tell you in the Nmap. These for the version number, S is for what service is running on the when it does the SYN scan. And you might be able to look at those version information, put it into Google, and try and find if there are vulnerabilities that exist. And that's how you would get to something like this, where you would just find like the CVE mirth, for example. So if I did the one that was in the example, you would be able to bring to this page. Sometimes you'll have, it even has, looks like a POC exploit on GitHub for that vulnerability. Sometimes it's as easy as I'll just copy the script, and paste it. For example, like this requires you to have Python installed and pip, very, very fun stuff. And you still have to put in the target URL, the listening port, and the listening host, and all of that information. But Metasploit might be a nice wraparound tool that does things nicely. And finally, we talked about privilege escalation. LinPeas is a very good and useful tool to do that. And I don't know why I'm frozen on all these places. Okay. Maybe you'll let me now? No. No, doesn't like this.
So Ethan, how'd you get into the no root shell on, how'd you get the no root shell on the box?
This one? No, I created a user for this one.
Oh.
This is our box that we set up. I
know.
made a no root user over there just
Oh,
to
okay.
show that I came from a no root standpoint and escalated myself to root. Anyways, I think that's.
Have like a little checklist. So the people who made LinPeas, they also run a website called Hattricks, which is just like a checklist. I know I reference it like all the time because I know I can't memorize every single technique that they talk about, or I don't know every single way they describe. Like, oh, this is vulnerable. Okay, what do I do about it? So I'm just gonna drop this checklist in announcements. Pretty good. I'll put it in. It's a pretty good resource for if you want to know how do I do this thing that they're asking, how do I use this technique. They'll probably have some information about it. Or, Google your best.
Okay, so hopefully I can come back onto this and keep demonstrating that privilege escalation if it wants to cooperate with me. Okay, maybe not. Okay, it doesn't like that. Is my VM going to run? Okay. Who remembers the IP address?
10.129. I forgot the rest.
So helpful. Oh, 58.116. Maybe you'll like it here. No. Where did my VPN go? Still running. Let's try this again. Hopefully you'll have so much trouble on the assignments.
Yeah,
Wait.
If you are having trouble, let us know. As sooner, preferably.
Oh, I still have a shell on here, okay.
Before I'm stopping it.
That's just the concentration.
Okay. Let's see if LinPeas will run nicer this time.
Are you able to re-demonstrate the Metasploit one? Do you want to try running Nano on a limited reverse shell?
Okay, let's see. Come back over here. Okay, so let's see if I run Nano over here. I don't think Nano even exists. Okay, something happened. Okay, now that's doing that. I don't even know how to exit.
Standard input is non-terminal. Yeah. Yeah. So that's the deal with some of these limited reverse shells because they rely on things like I don't even know what the term is, like pipes or special input redirects. Some features or expectations will not even be available in limited terminal. Like Nano invent. They open up like a new window and then they take over your terminal and you can run the program, right? In a limited shell, they're not going to be able to do that. So, or any commands that do, I don't know if like backgrounding job is like if you put an ampersand after a command, run it in the background. The point is like if you run a command and it doesn't immediately produce input or something, you're going to have issues if you're using a very limited reverse shell as opposed to something more advanced like interpreter. So that's why I brought up curl and wget. Sometimes you might not have the option to like echo file, redirect it into a, echo something, and put the script into a file or do something. You might just have to run curl and just get it that way.
That's what we spent 3 lectures on Linux commands, by the way, because this will all just be Linux commands. You don't really have any other option of doing anything else.
It's like, I'm trying to remember. It's basically curl, except.
The non-interactive network downloader, that's what it is. It's a GNU free utility to essentially get files from the web.
It can work in the background while the user is not logged on. So I mean, like, using it for reverse shell is basically the same thing, but wget is like, if I want to download a 25 gigabyte file from, I don't know, like an ISO for an operating system, I can just run wget in the background, I can have it resume.
Oh, that's cool.
It's just like curl, but it's slightly more features. Curl is just basically send the web request.
Yeah, like it takes the terminal.
Yeah.
That's why I was.
Yeah. If you run nano, I think you're gonna have to kill that shell, and then you're gonna have to rerun the exploit to get the shell back on. Mildly frustrating.
So yeah, wget is just like curl. I think it's an older version of curl, less powerful version of curl. That's my take on it. Okay. I guess linpys will take a while to run. So I'll just tell you that there is something interesting that will show up in /user/local/bin/notify.py. If I can kill this. Okay, it doesn't want to let me kill, so we'll just let that run. Will it do this? No, okay. 192.16, no, 10.129.58. That's why you should have tmux, and you can avoid all these SSH fun stuff. But unfortunately, this thing doesn't have tmux on there, so I'll just tell you that something in linpys will tell you there's something interesting going on over here, where you can see notify has read, write, and execute permissions by root. So when you execute this thing, it's executed by root. But Cedric has read permissions to this thing, so I can actually look at what's going on with notify.py.
What if just did that and you weren't no permissions at all for that file?
So permissions, you have read, write, and execute. So the first three are for whoever owns the file, so you'll always have two names. This is the owner, this is what group people are allowed.
Yeah, I
to access.
remember when you explained that, but like when I mean the full dash thing, what does that mean? Like,
Oh, those are just dashes like this. It's just dashes for the rest of them. Is that what you're talking about?
Yeah, like what does that mean? Like
That means they don't have that permission. This is always read permission, so they don't have write, execute, and everyone else doesn't have read, write, or execute
okay, so
permissions.
there's no
Dash means like none.
Yeah.
Like zero.
That's all. Thank you.
So we can actually take a look at this notify.py file. What did I do? Notif.py, not notify. Okay. So it's actually some sort of Python script that runs this local hosted web portal thing. And if you look through the code, you'll find something interesting over here where you have this eval function. And in Python, eval function just means execute this as a shell command. And the way you do that is it takes this template and it tries to parse that out and evaluate something in there with these brackets. So these brackets, there's two double brackets. The format strips away the first one, so these are all substituted with variables. And then this whole thing is because there's a separate double bracket. It tries to evaluate that string inside there to do this computation of date, time, now, year minus your year of birth. And it turns out that we can actually send something to this Python shell. If we can send something to this Python shell and somehow inject some command into this eval function over here, then we might be able to get to execute and hopefully retrieve that /root.txt file. And that's actually what we can do. And this is slightly more complex than what the class will require, because this requires you to draft up this whole XML payload, because this thing uses XML, and we'll actually use a wget to do that. So I'm just gonna write this up, I guess. So or not, since it doesn't want to let me do anything anymore.
Very nice.
But the idea is you'll craft an XML payload, and because this payload over here uses this /add patient endpoint, we will use that whole wget thing that we're talking about on the server. So we'll craft a wget payload. The server is on 127.0.0.1. There's a port address somewhere over here. Where is the port address? It's somewhere there.
I mean, what port is it running on? Oh wait, why does it say 54321?
Oh, it's 54321. Yeah, that's what it is. That's the port it's running on. Thank you. So we'll actually do this at the endpoint because it's a flat thing called add patient. And then we'll actually append a package. I think post equals like some a.xml file, and that's the XML file that we want to inject. So the question is, how does XML file look? Thank you for just getting rid of that for me. Let's come back over here. We want to inject something into this template over here. This template is passed over here via the XML packages, where you can have these are the items that we can inject. So inside this XML thing that will look like something like this, we will have something like first name, and then we have something, blah, 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 last name, blah, 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 blah. And all of these variables ended up getting passed into this template string over here. And because we know that when there is a brace over here, it will evaluate an expression, so we can actually just craft an XML page that has a brace. And very critically, that's why it's important, if you remember from Butler, that you have to do input sanitization, and they try to do that with this regex pattern right at the top over there. Pattern equals re.compile, make sure that it only has those symbols, and thankfully it had this nice little curly brace for us. And we can just do something like import os dot system, right? You can just execute something like that, and you can try to execute a shell, but for our purposes, we don't even need to do something that complicated. We just need to do some sort of file read, so we can do something like fopen. What is it? /root.txt, right? So something like that you craft in, put it into the whole XML package, feed it in, and because the server will just execute that code blindly, you should be able to get the root.txt. So that's how this whole thing looks like. The homework shouldn't be as complicated as this, but that's like a full step of how you would, go from privilege escalation via finding all these, interesting little vulnerabilities.
I mean, the core part of it is just the eval function. If you know anything about Python, eval is take whatever input. If it's Python input, just run it. So, I mean, it's in like the Python list of forbidden functions, similar to like, I don't know, gets. It's like the C buffer overflow functions. Eval is like one of the bad functions. You should be very, very careful with. Funnily enough, there are also eval functions in other programming languages used on the internet. So make of that what you will.
Almost every programming language has something like that. PHP has some sort of evaluation, and even C has like system calls that you can just run. So, because there just needs to be a way for you to somehow get things back from your terminal.
Alternatively, if you don't, you can just disable the function. But it looks like this, they do need something.
I mean, the safer way to do this is, of course, compute that without that sort of injection first. Then, like, this doesn't actually need to be in here. Like, there's no reason why this eval function needs to be. Like, you should have just calculated that and then fed that directly into the string itself. Then you could have avoided the whole eval function. So that's pretty much all I've got. Talked mostly about all the exploitation wget control is very useful. Metasploit, fantastic tool. And linps. Any question? No questions. I think that should pretty much cover like most of what people need to know for homework
Yeah.
4.
Pretty much. I mean, if there are
Starting after the exam tomorrow.
Yes.
Can you real quick go over the metasploit commands that you use?
Yes. So the metasploit commands. Okay, so that's just
we need to zoom in a little.
okay. So first of all, again, we can. We can go over first thing that we said was scanning, right? You might need to do db init to initialize the database because Metasploit actually uses Postgres SQL, or you can call it Postgres Squeal if you like. So it initializes this database, and that's what you save everything for. You might also need to run, before you even run MSF console, systemctl Postgres squeal start or something like that. So you might need to make sure that the database server is running. Metasploit uses Postgres squeal.
If you get
If you get an error, like
if
you
you
can
get
also
an error,
Google.
feel free to ask Google search Gemini.
Yeah, Google search will literally tell you that you'll need Postgres squeal. Anyway, so you run MSF console on Kali, and that brings you into here, MSF. Run db init, and then first thing again, reconnaissance db nmap.
Which all it does is just runs nmap, but it feeds the results into its database.
Right.
You could just run normal nmap.
You can also just run normal nmap, yes. And actually, you can run normal nmap, get all the results from nmap. It's going to save it as an XML file, and then feed it back into Metasploit later on.
Or you could just not use the database and just do.
Or you cannot use the database, right? For small things like this one server that only has 3 ports, maybe it doesn't make sense. But when you're scanning like a whole range of network, might make more sense for you to have a database to keep track of what you're doing. Then what we did was we looked at the search command, where we looked for a particular vulnerability. So you can actually search for a lot of things. You can literally type in CVE numbers. So if you know like 2023, 4906, for example, I don't know what that is. But you can literally type in this whole CVE name, or you can type in anything else, like maybe search for HTTP. Will that work? You can search for a lot of things. This is actually, there's a lot of different HTTP vulnerabilities. It'll give you all those different things with the CVE number on them. And there's so many that I don't think even bother listing with that. So there's these numbers over here, right? Up to 71 different HTTP exploits, it seems. And so after you found the right one that you want, if it exists, then you can just use the use command. The use command with either that direct number that you search for, or you can literally take the whole thing. So for example, that 177.7170, I can type in auxiliary/docs/http/ws docs. After the use, you will be put into something like this exploit over here. It might not be exploit, so if you're using something for, like, as we said earlier, there are 4 different modules: auxiliary, exploit, post, and payload. You might have something else over there, but exploit is usually the ones that people go for the most. But some vulnerabilities might actually have auxiliaries that you can use. So you get put into this screen over here with the whole full path name of what that CVE or the name of that exploit is. Then you do show options to look at all the options that you can set for that particular exploit. You can also just type in options. It's an alias for that. So options look like this again. And sometimes you might also want to set a different payload, so everything else is set whatever. So you can set L hosts, set R hosts, set payload, and you can also do show payloads. And that will show you all the different payloads that Metasploit comes with. So it's always those 409.
I think you can update, you can make it run updates to get new modules, but
So do all of those exports like come pre-installed already?
yes.
Yes.
You don't have to do like Metasploit install whatever exploit. They're bundled in with Metasploit classes.
And again, just because Metasploit doesn't have it doesn't mean it doesn't exist in the wild, right? It just means that you might need to go and find the GitHub repo that contains that proof of concept and then execute that without Metasploit's help. Any other questions? All right, I think that's it.
Alright, Assignment 4 is out. Happy hacking.
Yeah, start earlier.